Assalamu alaikum and hello everyone. I'm Ahmed Al from ISS-Yemen's academic committee, and I will be your host today. Okay, firstly, I would like to thank you all for participating today, and I would like to give a huge thank to our bootcamp's presenter, who is none other than Engineer Anas Amir, a recent graduate from UTM University. Anas Amir brings a wealth of experience to the table, having served as a senior Republican member at UTM. He also has many other achievements, including winning the prestigious IMDC Excellence Award and earning the title of TGL Crest Grand Design Champion in 2022. We are incredibly fortunate to have someone of his caliber to guide us in this exciting journey. So buckle up and get ready for an enriching experience as we explore the world of AI and machine learning with Python under Anas's expert guidance. Once again, thank you all for being here. I'm confident that you will all enjoy and benefit from this bootcamp. And let's get started. Okay, Anas, I'll pass the mic to you.
Okay, thank you for the introduction. I'll share my screen. Okay, can you see my screen?
Yes.
Okay. So welcome to the AI and ML with Python bootcamp. I am Anas Ismail, and this is brought to you by ISS-Yemen. So this is the overview of the entire bootcamp. So today we'll be doing the Python basics. Tomorrow we will learn OpenCV, and then on day 3, MediaPipe. Day 4, we will be learning text-to-speech and speech-to-text, and also reinforced learning. And on day 5, we'll be learning YOLO, the YOLO framework. And then on day 6 and 7, we will have a competition that we will announce the rules for later. So let's start for today, Python basics. So this is a little background about Python. Python is a high-level general purpose programming language. High level meaning that you don't have to know the hardware in order to write in Python, as opposed to maybe C, where you need to write it on a microcontroller maybe. So you need to have some knowledge of the hardware. So Python is high level, so you don't need to know the actual hardware. It can run on Windows, on Linux, etc. And it emphasizes readability. The most important thing is in Python is that it's easy to read and it's easy to use. And Python is also dynamically typed and garbage collected. I'll explain this later. And it has many already libraries, so you can use it for almost anything. So let's jump straight to VS Code. I assume that everyone has already installed VS Code and Python. I also want you to make sure that you've installed the Python extension inside VS Code. You can also install the Pylance extension for autocomplete. We won't be using this today, but in case later you want to use autocomplete, you can install Pylance. So once you open VS Code, you should have something like this. This is the interface. And the first thing we're going to do is to open a folder. If you don't have a folder, just create one. And then you should have the folder's name here. I'll give you like 2 minutes to create the folder, and then we'll continue. Okay, so once you've created your folder, the next step is to create the actual file, the Python file, and you can name it anything as long as it ends in .py. So let's call this maybe basics.py, py. This is our first Python file. So once you've created this Python file, you can start directly typing in Python. So the first thing that I want to show are the types in Python. So as I mentioned before, Python is a dynamically typed language. So you can say x is equal to something, 7, for example, and you don't have to define the type for x. Because it's dynamically typed, it will figure out that this is an integer. So you don't have to like say int x equals something. Okay. Yeah, you can create a new folder, or if you have an already existing folder, you can use the same folder. Okay. So if we run this, print x, this one is 7. So print will just output the variable or the string that you type here to the terminal. So this is already enough. This is a complete Python code. If we run this, we should get 7 in the terminal. Okay. So we can also check the type of x using the function type. This function will tell us the exact type of x since we have not explicitly defined it. So maybe if you want to know any variables type, we can use this function. It says that it's an integer. So let's change this to 7.0 maybe, and it should be a float now. Float. You can also assign a string like name. This should be a string. str is short for string. There are also other types in Python, but for now I'll introduce these. I'll get to the others later. Let's say you want to take input from the user. So we'll use the input function. Let's say user is equal. User is just a variable. The function is input. And then inside this function, you can type the prompt or the text that will be displayed to the user. Let's say, what's your name? Okay. Then we can print maybe your name is. And then to add the variable, you can just add a comma and then the variable name. This will print your name is and then whatever value is inside user. So if I run this, it asks what's your name. You can type Anas and then it says your name is Anas. Nice. Any questions so far? If you have questions at any time, you can ask in the chat or you can just unmute and ask directly. Okay. This is how you take an input. Let's say you want the input as a number. You will have to cast. Let's say the question is, what's your age? If we run this now, it will print. But let's say we want to do like a mathematical operation. User equals user plus 1. This will throw an error. Let's say your age next year is, if I type 21, for example, this is an error because the input returns a string. And then we're trying to add 1 to a string, which doesn't work. So we need to cast this. In Python, to cast something, you just type int or the type, and then open your brackets, put the variable you want to cast inside, and that's all. This way, we'll treat user as an integer that we can add to, and then we can run this. Let's say 21. Your age next year is 22. Okay. So this is casting. You can do, other than integer, you can do float, you can do string, and so on. Okay. The next thing I want to show, but before I move on, is there any question regarding data types or input? Okay, no questions. The next topic is conditions. If conditions in Python, there are no brackets for if conditions or for loops or while loops. Then you just put a colon and then indentation. I'll show you. Let's say x equals 5. Then we can say if x is less than 7, for example, and then print x is greater than 7, is less than 7. Okay. So the indentation here is very important because this is how Python knows that this is inside the if condition. You see, if I remove this indentation, there's a syntax error. It needs to be indented in order for the compiler to know that this statement is inside the if condition. If I were to write another statement here, let's say print something, this is not inside the if condition. This will run regardless of the if condition. If I want to include it in the if condition, then I have to also indent it to the same level as the previous one. Okay. So if I print x here, it will print whether it's less than or greater than, doesn't matter. It will print x. So let's run this. X is less than 7 and then 5. If we change this to, let's say 8, so it's no longer less than 7. So this won't run, but it will still print the value of x anyway, because it's not inside the if condition. If I put it inside the if condition, if I indent it, then nothing prints anymore. Okay. So indentation is very important in Python because this is how the compiler knows whether something is inside a certain paradigm or no. So that's how you define what's inside the if condition. You can also add stuff using the and keyword. So this is the same as this in C, if you've ever used C. In Python, it's and. So if x is less than 7, and let's say and greater than 2 or something, then let's return this to 5. Then this will only print if it's between these ranges. If you want or, it's just or instead of this in another programming language. Will just be or. Yeah. This is if you want one condition. But if you want multiple conditions, you can type else f. This is ELIF, which is short for else f. Else if x is greater than 7, maybe. Print x is greater than 7. So just like in any other programming language, this runs if this is not successful, and then this condition is true. So if this condition is false, moves on to this one, checks this condition. If it's true, runs this, otherwise nothing happens. So if we raise this to 9, x is greater than 7 should print. Okay. There's also the regular else, in case you don't want to check another condition, just else something, whatever happens. So if we set it to exactly 7 is equal to 7. So it's not going to be less than 7 or greater than 7. It's going to be exactly 7. So it will go to this else statement and it will print this out. X is equal to 7. Okay. Any question regarding conditions before I move on to loops? Okay. No questions. Let's move on to loops. There are two types of loops in Python, for loops and while loops. So for loops are used to loop over a certain number, a known number of elements. Let's say for x in range. Okay, this range function returns like an array depending on the value that you put inside. So this is range 5. So this means it starts from 0 until 4. It's exclusive to the number that you put inside. So 0, 1, 2, 3. 0, 1, 2, 3, 4, because we put in 5. So if we try to print x, it will print. So this is a loop. It will repeat for 5 times. X will start at 0, and then the last value will be 4. 0, 1, 2, 3, 4. Okay. You can also, if you define, this is a list data type. Let's change this to I. So a list is the same as like an array in other programming languages. You can type on like comma, 2, 4, 5, and so on. And then instead of using range, you can say for I and X, for example, if you want to like loop over the elements inside X, inside this list. So now if we print I, it will be 1, and then 3, and then 4, and so on. The elements inside this list. 1, 3, 4, 5, 6. So this is another way that you might use for the for loop, either to repeat something for a known number of times, or to like iterate over the items inside a list or the components of a list. Okay. The second type of loops is a while loop. A while loop requires a condition, and as long as this condition is true, the loop will keep repeating. Once this condition becomes false, then the loop will break. So let's say x equals 0, and then while x is less than 4, we will keep increasing x plus equal 1. This means that it will increment x by 1. And then let's print x. So it will start as 0, then 1, 2, 3. Once it becomes 4, the condition will be false, and then it will go up. 1, 2, 3, 4, and then it goes up. Okay. These are the loops in Python. Any question about loops? This is just the most basic form that you can implement these loops. Later on, we will use these loops, and then I guess with more examples, you should understand more. Okay, let's continue. Just now I mentioned lists. There are different types of like multiple elements objects in Python. A list is one of them. There's also a tuple, something called a tuple. So a tuple is defined by these parentheses instead of these square brackets. Let's say 2 and 4, maybe. So the difference is between the list and the tuple is the list can be assigned to. You can change, let's say, x of 0. I want it to be now 5 instead of 1. Okay, so this works. If I print the whole array x, it will be now 5, 2, 3, and so on and so on. Okay, 5, 2, 3, 5, 5. But I cannot do this with a tuple. If I try to assign to a tuple something, it will return an error. So this is a tuple. You cannot support item. It doesn't support item assign. Okay, so this is the tuple is usually passed as an argument to some functions. You can use it for like stuff lists that you don't intend to change, something that is fixed. Yeah, that's the general use of tuples. Lists also have functions. You can use the append function to add something at the end of the list. So I can append maybe 6 at the end. Let's append x. So 1, 2, 3, 4, 1, 2, 3, 5, 5, 6. It adds at the end. You can also insert something at a specific index, like inserting at 1. Let's insert 4 or something. So now when we print at the second position, it's now 4, and then the rest is the same. You can also do something which is sorting. It has the sort method. Sort will just arrange them by value. And this is useful in case you don't want to implement your own sorting algorithm. And this uses dim sort, if you know the sorting algorithm. So if I do this, it will now sort it from 1, 2, 3, 4, 5, 5, 6. Okay. So these are lists and tuples. There's also dictionaries. Dictionaries are defined by these like curly brackets. And dictionaries are like a value stored, but instead of an index, instead of like being 0, 1, 2, 3, like would be in a normal list, it has like a key, a value, a string that is attached to. So I can say like name, and then a colon, and then Anas, for example, comma, let's say age, colon, 21, so on. So you would use this by printing, let's say, Z, and then instead of writing a number here, you would type name. So return me, this is called a key for the dictionary. And then it will return the value that was assigned to this key. So in this case, it should return Alice. Okay, I'll commit this. Alice. So this is how dictionaries work. And you can use them for a lot of useful operations, especially when you want to like store something, but not as an index of an array, but instead like as a value, as a string. So something in front of a string, something like a name or something else. Okay. So any question about these types of lists or like types of arrays? Okay, no. The first one and a tuple. Okay, the first one is a list, and this is a tuple. A tuple, you cannot assign anything to the tuple. Once you set, this is 2 and 4, for example, you cannot say y of 0 is equal to something else. This will give you an error because this is a tuple and it doesn't support the item assignment. Okay, but for a list, you can do this. You can say x of the index 0 is now equal to 5, and it prints normal. Doesn't throw any error. Can print x of 0. And it prints. Right, for insert function. Yeah. Can we create an array inside? Oh, okay. I'll do the insert function first. The insert function is just dot insert, and then you specify the index that you want to insert in. So this index is 0, for example. So if I want to put something before this one, I'll type 0, and then let's say 5 or something. So now if I print x of 0, or let's print the entire x list, it will insert a 5 at the first position, at the 0 position. Okay. And then the rest of the list is still the same. It just inserts something. Yeah. It doesn't replace, it just adds at this index. It inserts. If I type 1, if I change to 1, it will just insert a 5 at the second position between the 1 and the 2. 1, 5, 2, 3, 5, 5. It doesn't replace anything, it just adds something to the list. Okay. And then can we create an array inside an array? You can do a 2-dimensional array, which is something like this. And then continue adding an array, say 2, 3, 4, 5, something like this. These are two arrays. It's a 2-dimensional array. And then you can say for this one, print the first array, the first index, and so on. So this will print of the first array, the first one, which is 1. Okay. You can go to the second array and print maybe the second index, or maybe the third index. So this is 5. Okay. So yeah, you can have an array of arrays. Yeah, the index always starts with 0. Any other question? Okay. If no question, I will move on to functions. So functions in Python will also use the indentation to like specify what's inside the function. And we'll use the def keyword, which is like define. And let's say define add. And then you can add the arguments here to the function. Let's say x and y, and then a column. This way inside, you can say x plus y or something equals z equals x plus y. So we add. And then you can return something, return z, for example. So this function takes two variables, adds them together, and then returns this value. So let's say I can say here result equals add, and then 2 and 5. Then let's print result. This will output 7. Okay, so this is how you define a function. You use the def keyword, and then you add the name of the function. Inside the brackets, you add the arguments separated by commas, and then you add a column. And then whatever is inside the function, the lines inside the function should be indented. And you can return something, or you can just, if you want to return something, then return something. If it's more convenient to your code. If you don't want, then you can just omit this. Something to note is the variables inside the function are not global. So let's say I define z here as 2, and I don't use this. Let's say I just run at 2 and 5. Okay. If I try to print z, it will not print 7 because this z is just inside this function. It's not global. It's not changing the global z. The global z is still 2. If I wanted to change, then I would type global z inside the function. This tells Python that I'm using the global z, not just another z that I created. So any changes that happen to this z will be reflected in the actual z outside. So now if I print, it's 7 because it changed inside. Otherwise, any variable you declare inside the function will just be inside the function, not outside. Even if they have the same name, it won't change the variables outside. Okay. Any question for functions? More than 2 variables? Yeah, sure. Can contain as many variables as you want it to contain. If you mean arguments, you can add more. Say something else, sorry. And inside too, yeah, you can create as many variables as you want inside. K equals something, and so on. And I talk about lambda. I can, sure. Okay. So lambda is like a definition. So you can say x is equal to lambda a plus 10. Okay. So now if I print, it's like a function, but it's like a definition. If you've ever used C, you can define, let's say hashtag define something, and then pass a variable a or something, and then you do something to a plus 10, a multiply something, and so on. This is the same idea. So we're saying it's like a function prototype almost, but it's just a definition. So this, it's like an anonymous function. Yeah, it's like, you can say it's an anonymous function. This should print 15. So the variable that we pass to the lambda function here, or to x, is a. So it's saying for a, make it a plus 10. So now for 5, it would be 5 plus 10, which is 15. Okay. It's just a quick way if you want to define a function, but it's really short. Maybe you just want to edit one variable, so you don't need to like write an entire function for this. It might be especially useful for like conversion, for example, between degree and radians or something like this. So you like multiply by 180 over 3.14, for example, something like this, or over pi. So you don't have to say call this degree to rad or something like this. So you can call degree to rad and continue. It's useful for stuff like this. You don't have to write the entire function. You can just write one line and then use it throughout the code. Okay. Any other questions regarding functions or lambda? This switched, by the way, should be like rad to degree. What is lambda? In Python, it's a keyword for like a function definition. It's like you're saying that this equals, if it's given this, it will output this, something like this. Okay. If read to a degree, if this word is given a variable, let's call it a, which is in this case 5, then it will multiply it by this, or it will add something to this, and so on. Okay. Can do something also like exponent, and then it's equal to a by a, something like this, squared. Great. Okay. Okay, I'll move on to classes. Okay. If you want to do something, if you want to define an object or use object-oriented programming in Python, they have a classes keyword, a class, and then you define the name of the class. Let's create a person class person. And then any class is going to have an init function. So this function is like the initialization of the class. When you pass later on the variables, like the arguments to this class, it will go to the init function. So all you have to do is define init like this, and then whatever you want to pass. Okay. And most of the time, or like almost always, any function inside the class will have the self keyword. It's like referring to the class itself. Okay. And then let's say this class person takes a name and an age. Inside, you can say that there's a variable called name, and you notice I've typed self.name. This self dot makes Python know that this is a member of this class. So now we have a variable inside this class called name, and then let's set it to name, which is the argument that we're getting. Let's also add self.age equals age. So this is one function. This will run when you call the person class, when you like define something, defining an object for this class. You can also add more functions like maybe increase age. We're going to pass self as usual. Increase age. And then we'll say that self.age plus equals 1. We increment this stored age for this person. Okay. So now what we can do, that we've defined this person class, we can say that Anas is a variable. Its type is this class person. His name is Anas, and he's 21 years old. Okay. So this now is an object. Inside it has a name and an age and so on. And we've defined it using this person class. And you can see that the arguments to the init function are the arguments that you can pass during the initialization of this class. So this is the name here, and this is the age. Okay. And then we can call something, the function inside, which is anas.increase age. So this increases the age. We can print then anas.age, and it should be 22. Okay, 22. This is like the most basic class that you can do. The next thing you can do is inherit from a class that is already existing and add stuff to it. So you can say class student, for example, and then inside these brackets, you pass in person. So this says that this class is uh, a child of the person class. So it inherits all the stuff inside, all the variables inside and so on. So we can just add to them, but we need, if we want to access the the parent class, we can use the super keyword I'll show you just now. So let's define another function. Let's say add uni or change uni. And we'll take self and uni. Okay. Then inside we can add another variable, class variable. It's called self uni. Then is equal to the uni that we just passed. So this class student extends the class person, has everything inside, and then we added something, we changed something inside. So now instead of defining person, we can define student. And then maybe dot change uni. Then let's say UTM. Then we can print the uni. Okay, UTM. It still keeps the previous stuff, name and age, although we didn't like specify them inside this student class, but it inherited the person class, and so it still has the stuff inside, the variables inside, and the functions and so on. We can also increase age and so on. Increase age. 22. So it inherits all the functions and all the variables that were inside the parent class, and then you can add more functions and so on. Okay. Any question about classes? Let's say, yeah, about the super word that I just mentioned. There's a keyword called super. So super, yep. And this allows you to like access the variables at the parent class. So usually pass self, and then you can like access the members that were in the parent class inside here if you want to change. Let me double check. Yeah, you can access supposedly the, yeah, increase age, the name and so on, the variables that were in the parent class. You can access them in case you want to change them because they're not defined in this child class. So if you want to access the parent, you can say super dot then the name. So I can change the name inside, change it to like Adam or something. So every time I change uni now, the person's name should change to Adam, even though like the variable name is not defined inside this class, but we can access the stuff inside the parent's class using the super keyword or the super function. Oh, it says that it doesn't have anything called name. You need to initialize first. Super init. Okay. If you want to change the initialization, super dot init, and then you pass something else, and then you can use the functions inside, name and so on. Okay. Anyone has any question regarding classes, inheritance, and so on? Okay. What was the code for? We're just going through the basics of Python, not for something specific. I'm just giving examples on how to use different classes, how to use keywords, loops, and so on. So yeah. Okay. If no other questions, I would also like to show you something called try and except. So let's say you have something that might fail, some code that might fail. You can enclose this code and then try and accept paradigm. So let's say x is equal to 7 or x is equal to a string. Okay. And then try z is equal to x plus 7. And we know that we cannot add a string to an integer. So this is going to fail for this scenario at least. And then here, let's say exception occurred or something like this. So whatever we put inside the try, it will try to do. And then if something happened, it won't like stop the code. It will just go to the except block and then run the stuff inside. So this should when exception occurred. But otherwise, if there are no problems in the try block, then it should just run the try block. Usually this is used for like maybe an image stream that you're not sure is always going to be there. Maybe the camera closes or something, or any other error that might occur, but you don't want the Python code to stop working. Okay. Any question about this? Okay. I will move on. There's something else. There is the with keyword. So you can say with x as something, like redefine x as another variable. Let's say with x as name. And then add the column, then print name. So if you run this, we'll say that it doesn't support the context manager protocol because this is usually used in an image stream or an input stream, an audio stream, so on. So you would have something like an audio text or a text file. And then using this, you will be able to like get the individual data one by one inside the stream of data. Usually this is what the with keyword is used for. For now, yeah, this one run. But we'll use it later for the text-to-speech and for the media pipe days. Okay. Any question in general for any of the stuff that we went through? What super does? Okay. Super is like a way to access the parent of a class. So let me like go back to the classes. Okay. So let's say that you have the parent class person, okay? And then another child class, which is student. And you want to access the parent class. Let's say you want to run the initialization function. So what you can do, let's say inside this initialization function, inside this class, you can define another initialization function in it, for example. Yeah, it automatically filled in the super. And then this means that I'm also going to run the initialization for the parent class, which is person, with these variables. Okay. So this is like accessing the parent, which is person, which is the one we ran here. And then I'm running the initialization function inside the person class with the same variables that I have. Okay. It's like accessing the parent class. Okay. Why do we need? Because we don't want to rewrite everything inside the person class. So instead of writing another definition with the same stuff, with passing the same arguments, you can just say, just run the initialization of the parent function. Okay. Yeah, it's already it's already copied, but it's good to represent because this is ran automatically, but you should include it inside because maybe you want to change something after you initialize. Let's say I want to take something else, not just the name and age. I want to take also the uni that he started in. And then after I initialize this, I say subgroup uni is equal to uni. So I can have my own initialization function. Okay. But I can still include the initialization function that the parent has and then add something to it. Add maybe the uni that the student has. So it will run the parent's function and then I can do something else. Otherwise, if I don't include this at all, then it will just run the parent's function, but I won't add anything to it. If I want it to stay the same as the parent, then yeah, sure, you can not you can remove this. But if you want to change something, you want to add maybe an argument. Now you want to include also the uni, for example. Then you have to include also the super function in order to run, and then add whatever you want to add. Okay. Why did you not include self? It is included here for this and this. For this init function, self is like referring to the same class. So I'm not referring to this class, I'm referring to the parent's class. So in this call, I don't have to use self. I only have to use self with the functions that I define inside the class. But if I'm calling another class's function, then I don't need to include self. Okay. What is the purpose of a class? The purpose is you want something to treat as an object that you can later access and change the variables inside. It makes like the code cleaner to see. You can represent instead of like creating a name and an age for every person. Let's say you have 5 people that you want to include in your code. Normally, what you do without classes, you just define like variables name, name1, name2, name3, and so on, which the code will look like messy after a while. But if you use classes, you can just define this person equals this class, and so on, and so on, and so on. You can repeat, you can reuse the same block of code for multiple people without your code looking messy, and so on. And it's especially useful for libraries. If you're writing a library and you want other people to use this library, you can include this module will be a class and then it has functions inside that you can call and so on. Okay. Any other questions? If we didn't include super, it's okay, right? Yeah, if you don't want to change the initialization function, you can just commit all of this. It will still call the parent's initialization function. If you don't want to change like anything, if you don't want to add something else, a new argument or do something else inside, then it's okay. You don't need to call. But if you write the initialization function, you can not include this and then repeat the same, like do something else. Self.name is equal to name and so on. If you don't want to inherit the same initialization or just run it at all, yeah, it's fine. You can do this too. You can do this. You can say like name plus something else, whatever you want. It's just something for convenience. If you want to run the initialization function, then it's okay. To add a variable to class. Yeah, I guess. It's just convenient to call the function that is in the parent class. You can include it or not include it. It's not necessary. Okay. Anything else that you want to ask about? Whether I've like mentioned it or not. Anything relating to the Python basics? Or if you want me to repeat something, I can repeat it. Okay. How to use this code as your own library. Okay. Yeah, sure. You can import stuff from other files. Let's create maybe a new file here and call it maybe the person class. So bye. And let's copy this and put it there. So now, okay, we don't have the class definitions here, but in Python, you can import other files and say import and then person class, or you can say from person class, and then you can import a specific class, import student maybe. So this will be like your own library. You can write something here inside a class, and then you can import it here and then use it in your code. So this is like cleaner if you're writing something, if you're working on a huge project, then it's cleaner to divide all the modules into classes and then include them in separate files or in one major library file and then import it to your project. This way, it's much more readable. Okay. So the methods can be used as objects after you import. Um, the functions can be used uh, not as objects. The classes are the like this is an object. Anything that you use a class to define is an object. NS is an object. And you can access the functions inside this class, like change uni and increase age and so on. So yeah, once you define that this is an object of this class, you can access all the functions inside this class, whether it's change uni, increase age, and so on, if you add more functions. They can all be used after you import. You can also like define functions that are not in classes, like you can say define add or something. Y, and then return x plus y. Here you have to import this, let's say from present class, import add, can import this function also, and then use this this function. As long as you import this Python file, you can import all the functions inside and all the classes inside. Accessing object is a class with its own methods. Yeah, an object is a class, is like a member of a class with its own methods. Each class would have its own methods or functions. And then this object is storing its own information, like its own name, age, and so on, is separate from other, like I can create another student, give them their own name and everything, and they will have like completely separate functions and methods. The functions and the methods inside will only change this specific student. If I change this uni, it will only change this object's uni and so on. Okay. So this way you can have like multiple stuff without filling your code with with lots of variables. Okay. Is there a faster way to apply a class to an object, like using a map? Uh, there are maps in Python, can map multiple instances to, I'll show you, it's easier to show. There's a function called map, and then you can use it to like map parts. Uh, let's say you have a function. Let's define a function, and let's make it like print the length of something. Okay, so let's say print length. And this takes a list or an array or a string. Let's call it string. Stone. Okay. And then prints the length of the string. Okay. And you can use the map function, let's say map, and then a function, let's say this one, print length, and then the stuff that you want to map. So what will this will do is what this will do is do this function or apply this function to multiple to all these strings. Say banana and then orange, for example. So this function will run for each one of these. It will map this function to each one of these variables. Yeah, true. Oh, okay, let me comment these first. Oh, okay, it ran, but I don't think it printed the lengths of the objects. And let's make it just return the the length and then store it somewhere. Let's say x is equal to turn the length. So for each of these strings, it will return the length of this. So we have another list, which is x, that contains the length of each one of these. So yeah, this is a map object. Okay. And we can access the stuff inside this map. It is like we can say like this, x0, and the first, oh, it's not subscriptable, I think. Let me see. Mm, Okay, you can just cast it to a list and then print it. Yeah, 566. Okay. So what I did now is just cast the map that I got from this into a list so that we can print it and maybe edit this map. So yeah, that's how you can like show and this map can be used for more than just functions. Like you can like cast any map any operation. Maybe I'm just searching for an example to show you. Seems like it can mostly be used just for functions, at least in Python. But if you want to create like multiple objects, you might need to loop through and then assign the name and so on for each value. Uh, Maybe there is a way to perhaps create multiple classes using map, but I think it's not necessary, at least for this course. Yeah. Any other question? Okay. if you have any questions for the basics, because later we will just go through the modules. Inheritances, okay. The inheritance is just the parent and child relationship that I just demonstrated. You have a parent class and then a child class. So this is called inheriting the parent class, uh, like functions and values and so on. Okay. This is what they refer to as inheritance, the relationship between a parent class and a child class. Okay. So this is an inheritance. This student class is inheriting the person class. Static method. Okay. A static method is just a built-in function that returns. Okay, I'll just show you. So let's say we have a function. Let's comment this. By the way, to comment is like control and the forward slash, or you can just add this hashtag in front of the object, in front of the line that you want to comment. Okay. Okay. For static methods, let's say that you have a class like this one that increases the age. Okay. And then you can change this method to a static method, or like you can define this as a static method. And then when you use it, it will be like, uh, let me just show you if I can find an example. This. 1 second, I'll answer this question and then see your question. Okay, for the static method, let's say that you define a function inside a class like this one, change uni, and then let's say you define a member of this class, or you can just set, let's say, student dot change uni is equal to static method, and then type in the method that you want to map this method to. So it converts a function to a static method. And this static method does not receive like the first argument, which is in this case the self. So it will just be like a normal function that you can use maybe outside the class. So you can say like student change uni, then like an argument uni, for example. Okay. Or like, yeah, I don't think you don't need to. Okay, change uni. So this way, this change uni function doesn't require the self instructor or the like the first argument anymore. You can still call it. You can still say, uh, but this is usually done with something like add. Like if we put this inside, so a function that returns something. So you can say define add, and then this one add, add. Then later you can say, let's say sum is equal to student.add, and then you can add it. Student is just the name of the class. It's not a specific member of this. It's not like an object. We then define, let's say, NS equals a certain student. But now that we've stripped it, like it doesn't have the self anymore. I mean, it never had to begin with, but now we added it. And then you can use it normally without being in the context of a certain object. So now we can just add like two numbers and then print sum. And then this should work normally. Okay, this one is required positional argument y. Okay. No, I think you have to not have self to begin with. Yeah, this way. So this is like if you want to use a function that is inside a certain class, but not necessarily with an object. So you define it to use it like this way. And then you need to say that it's a static method so that you'll be able to use it without defining a certain object. And now it should run, yeah, so okay. So this is the static method. Okay, next. Can a child class have a child class, or is it only okay child classes for a parent class? You can have as much child classes as you want. You can stack classes. Let's say class, I don't know, ICGB, and this extends student, and so on. And you can keep creating as much children as you want for the classes. Okay. So this is like the relation of this to this is child to parent. But this doesn't change that this also can be used. Yeah. A static method is like calling a function that is inside a class or inside, it's not inside an object yet, it's inside a class. And then you don't want to call it for a specific object. You want to like get something from, return something from this function or like use it generally, not relating to a certain object. Okay. Any more questions? Especially regarding the basics of using Python itself, because we'll be using we'll be skipping over the basics once we start tomorrow. So if you have any question about the basics today, so that tomorrow you can directly focus on the library that we'll be using. If you've missed anything, I can repeat. Try except, okay. Try except is like, uh, we'll try running these lines, and then if these lines don't work or get an error, then we'll go to the except scenario. So let's run a code that we know will fail, like just now, x plus 7, z equals x plus 7. And then except if an exception happens, if something wrong happens, then run this code. Let's say print exception. Yeah. What is the self and define it? Self is referring to the object itself. So the self is referring to the instance of a student. So if I say Anas is equal to student, the self in this case is referring to Anas, or the object that you're defining. So I'm saying that self, which is Anas, dot name will become name, and so on and so on. And it's passed automatically because we're assigning this to something. Yeah, tomorrow we'll be using OpenCV. Okay, so for this, it's gonna give us an exception because you cannot add a string to an integer. So this prevented our program from stopping. Exercises to practice for tomorrow, sure. I will give you exercises. Okay. So for this try and except, if this doesn't work, there's an error for some reason, then it will go to the except code and then we'll run the except code. But it won't stop the program. If I print something afterwards, if I print hi, it will still print hi, exception and then hi. But if I don't use this, if I don't use try and except, and I try to do something like this, then it will just give me an error and it will stop the program. Do spaces sometimes. Yeah, it's not like if else, there's no condition. It's just that if something happens in this code, if an error happens, don't stop the code, like don't stop running. I was expecting there to be an error because I put try and except. So if this happens, just print, just let me know, and then continue running the code, or like do something else and then continue running the spaces sometimes have syntax errors. It depends because the indentation is very important for Python. So you cannot just, this causes the entire thing to be an error because it has to be on the same level. Unless it's indented to show that it's inside a certain bracket, an if statement, a while loop, and so on, then it needs to be indented. And then if you include like an if statement inside something else, let's say, then what's inside the if statement has to be even more indented, okay? Oh, there's something called pass, which means just pass. I don't want to write anything here now. So just pass, continue. Because if you leave it empty, it will give you like a syntax error. So pass is just do nothing. Okay. So it's not like that spaces sometimes give syntax errors. It's just you need to make sure that you have everything that's on the same level with the same indentation, the same either like spaces or nothing, or so on. But like if it's something like this, as long as I increase all of them, it shouldn't be an error because they're all on the same level. But if I just increase one of them, then yeah. Okay. Mm. Generally, if you're using a library, you just need to know that you can import stuff from the library and then use it. And it depends on the specific library how we'll use this. But as long as you know this, it should be fine. You should know the assignment, like any variable that you can do this x plus 1 or something like this. As long as you've defined x before, say x equals 0, x equals x plus 1. So you're assigning x to the same value, whatever it was, then plus 1. It shouldn't be that hard. Like libraries don't require that much knowledge. You just import the library and then use the functions that they provide. Okay. And then we'll go, like, depending on the library, we'll explain more on what each library requires. Maybe later I'll share in the group the installations. Maybe for tomorrow for OpenCV, you'll need to run something to install OpenCV. I'll share this in the group. Or maybe I can demonstrate now. You can run the command pip. Oh, you to the present class. Okay. Okay, I've gone back to the present class. How can we use the add method? Oh, you mean inside the student? If say we had self in the class. If you had self for this add, then it won't be a static method like this. It will just be same as we used other functions. We just define someone like this. So student, pass a name, and age, say 21. So let's include the uni. Why not? Oh, TM. So it will be just as using any other function, just dot add and then something. You can also return stuff. It's the same. It's just like there's no need if you're using this and it has no relation to the class. Oh, you mean and the class itself? We'll just call self dot and then the name of the thing. We can say self dot add and then so on. Self here is just replacing the future object. Self dot add and then add something. anytime you want to refer to something inside the class that will be unique to every instance of this class, every object, then you need to include self. When using functions and that are inside the class, you need to use self also, or variables or functions. Yeah. Welcome. Okay. For installation of libraries, you can type Python m, yeah, pip install OpenCV Python. And if pip doesn't work for you for some reason, you can basically like you can add Python m and then pip install OpenCV Python. We'll use this tomorrow. I'll also send this to the group later, so you can install this. Yeah, I already have it, so it should like just already satisfied. That's it. Inside the terminal. If you don't have this terminal, you can go to view and then terminal. Here. I just open the terminal. Okay. I think if no one else has any question for today, we can end here. I'll pass to the facilitators.
All right. Thank you, Anas, for presenting today. And thank you, everyone, for the participation. Can you all please turn on your camera so we can take a group photo before we end the session? What about the rest? Can you turn on your camera? All right, we already took the picture. Thank you, everyone. And see you tomorrow, inshallah, same time.